Okay, we'll work through the exam 1 from fall 2010 here. Let's see, we'll get started. When you have a conversion problem, we don't expect you to know things like rods, but we will give you those conversions. That's on the first page of this exams. So to work this problem, we're going to start with 2 rods. We're given the fact that one rod is equal to 16.5 feet. Okay, we want to get to meters. So I don't know the conversion, and we expect you to know conversions like 1 foot, 12 inches. Okay, and 1 inch, 2.54 centimeters, and 100 centimeters in a meter. So we can multiply that out real quickly. 2 times 16.5 times, okay, 12 times 2.54 divided by 100. Double check my typing. Looks good. 10.06. Okay, units of meters. And we'll use 3 significant digits because that's what the instructions say. So 10.1 meters. Make sure you get units and round off your answer for each problem. Write this vector in component ij form. Okay, so this one, we have a component, use that coordinate system. We have a component going down for the y, going over for the x. This is the opposite side, so that's going to be 180 sine 40. This is the adjacent side, so this is going to be 180 cosine 40. Get those worked out. 138. And change that to sine. That gives us 116. Alright, be careful with the signs. So we'll go back to here. In the x we have, come on, don't scroll on me. In the x we have positive 116. So write that as 116 I. In the y we have a negative j. And make sure and get units on here. So units of eddies. Okay. What is the magnitude of the displacement vector from S1 to S2? So if we go from a position S1 to a position S2, that's going to be S2 minus S1 is equal to delta S. I'm writing it this way because I can write S2 up here, 18I minus 7J, 60I minus 7J. I'm subtracting. You can only subtract vectors if they're in the same direction. You can only work with their magnitudes if they're in the same direction. In this case, we're subtracting. We get minus 42I plus 0J. 7 minus and minus 7. So the magnitude of delta S is just 42, and then units are going to come from there. Okay, moving right along. Number 4, the volume of football, 3.75 times 10 to the minus third cubic meters. Volume of scale model is 20 times longer. So this is a linear scale. So to get the volume of the actual, it's actually going to be bigger. So I have to cube the linear scale factor. So pretty simple. exponential notations right there, -3. And looks like that number is 30 cubic meters. So we'll fill that in, and we'll work the next set of problems in the next video.